We now know how to integrate any power of x, some basic functions, constant multiples, and sums. And the way we figured out how to integrate each of these was to think back to how a differentiation works and go backwards. Now we also use the chain rule for differentiation. So if we can recognize an integrand to be the result of using the chain rule, then we can again think backwards to find its antiderivative. Let's try a couple of examples. First, what function can we differentiate to get 100 times 3 plus x to the 99th power? Well, we can expand this 99th power and integrate each term one by one, but we can be much faster. We know that the derivative of the 100th power of a variable is proportional to its 99th power. So let's make a guess. Let's try to differentiate 3 plus x to the 100th power and see what we get. Using the chain rule, we get 100 times 3 plus x to the 99th power times the derivative of 3 plus x, which is just 1. So indeed our guess was correct. The integral is 3 plus x to the 100th plus c. Let's look at another example. What function can we differentiate to get 3 times sine x squared times cosine x? The integrand here is sine x inside the square function times cos x, which is the derivative of sine. So this looks like the result of differentiating a function of sine x using the chain rule. Since we have the square of sine x here, let's guess the integral to be the cube of sine x. Let's check if our guess is correct. The derivative of sine cubed is 3 times sine squared times the derivative of sine, which is cos x. So indeed, the integral of 3 sine x squared cos x is sine cubed x plus c. What do these two examples have in common? In both cases, the integrand consists of a function, let's call it u, inside another function, then multiplied by the derivative of u. Recall, this is what the result of the chain rule always looks like. So when you spot this pattern, you can guess the integral with the chain rule in mind, and then verify by differentiating your guess. Soon, we will learn a more systematic but sometimes slower way to integrate functions that we have recognized to be of this form. It is called the method of substitution. Right now, let's do some practice with recognizing the pattern and guessing the integral with the chain rule in mind.